So welcome back, students. Now, we are in the part 3 of the topic 1, which is the review of relevant geodesy concepts, reference systems and reference frames, and geodetic data. First, let us recall the meaning of geodesy. So di pasabot sa geodesy. Geodesy means it is one of the earth sciences, or it comes from the modern Latin word geodesia, which means geo is earth and dien is to divide. And if we are going to combine these two words, it will be dividing the earth. So in short, geodesy is dividing the earth. So there are also familiar earth sciences or geosciences. One of these is the geography. Geography is describing what you find where on the earth. Like for example, the land, water, climate, vegetation, and man's habitat in relation to this. We have also geology, which studies the rock formation and their history. We have also geomorphology, which describes the landforms and their evolution, and the geophysics, which studies the physical forces that shape the earth. So, geodesy is less well known, although geodesy is the oldest of the geosciences. So, kung maingon tag geodesy, unsa day ginabuhat ani? Unsay naaani sa geodesy? So, the following is an initiation of the mysteries of geodetic concepts. It is centered on the three major topics, which is the studying on the shape and size of the earth, the gravity field on the earth, and the point positioning. So we all know, I thought na human naman jud mo og geodesy subject no, kay nakaabot naman mo aning geodetic surveying. So kung may tag size and shape of the earth, so it talks merely on the geometric geodesy, and if we talk about gravity field, so physical geodesy pud na siya. And pag point positioning, more on satellite geodesy, or pwede po siya sa geometric geodesy. So here is the technical definition of geodesy. According to F.R. Helmert, the classical definition of geodesy is the science of the measurement and mapping of the Earth's surface. And also according from the Geodetic Glossary in GS 2009, geodesy can be defined as the science concerned with the determining of the size and shape of the earth, or it is the science that locates position on the earth and determines the earth's gravity field. Another definition is from Smith, 1997. So according sa iya, it is the science that determines the figure of the earth and the interrelation of selected points on its surface by either direct or indirect techniques. Another definition of geodesy is a branch of applied mathematics that includes observation for determining the size and shape of the earth and defining coordinate systems for the three-dimensional positioning and the variation of the phenomena near to or on the surface of the earth, such as gravity, the tides, earth rotation, crustal movement, and deflection of the plumb line. So those phenomena are studied in geodesy, no? The tectonic deformation, crustal movement, deflection of the plumb line, and so on. So in other countries, specifically in European, geodesy is used as the term in an umbrella manner to describe all of the activities such as valuation or land valuation, land management, cartography or the study of map making, setting out surveys such as construction or engineering surveys, underground surveys, no? Example is the mine surveying, national mapping, boundary surveys, land information systems, and other activities except the traditional definition of geodesy. So here is the illustration that shows different surfaces of the Earth, or how to approximate the surface of the Earth. So we have the surface here, the terrain, the geoid, and the ellipsoid. So here is another representation. No? So the dark blue, or the blue-green, that represents the Earth's surface or the terrain. And we have also the geoid. So the geoid pala is the sea surface and its extension towards the continents or the land parts. And si ellipsoid, siya ang nag-approximate sa geoid na surface. And we have also here, I am going to introduce now the different heights, no, to have the relationship between these surfaces. So para mas madali na to siya masabtan and na ay relationship between these surfaces, we have these heights or formula. First is the orthometric height. So anang h nga dako diha is denoted by big H of a point is a distance along the plumb line from the point to the geoid. So when we say plumb line, it is the direction parallel to the gravity towards the center of the Earth, padulong sa center sa Earth. So kung asa padulong ang direction sa imong gravity, dito pod ang plumb line. And again, orthometric height is distance along plumb line from the point, or kung asa ka nagtindog sa Earth's surface, to the geoid, or kanang dark blue nga color sa geoid. No? So denoted by big H. And geoid, again, we're going to define, it is the imaginary surface that coincides the mean sea level in the ocean and its extension through the continents. So from the sea surface, extended padulong sa continents or landforms. We have also here ellipsoidal height, or kanang H nga gamay. So ellipsoidal height of a point on the Earth's surface is the distance from the point, or kung asa ka nagtindog, padulong sa ellipsoid surface. Orthometric height from the point to the geoid, and ellipsoidal height from the point to the ellipsoid. Again, si ellipsoidal height, dito gyapon siya, ang direction gyapon niya is same sa imuhang kung asa padulong ang imong gravity towards the Earth. Again, so naman the definition sa plumb line. Plumb line is a line that corresponds to the direction of the gravity. So, di ba, malakong iyon ganina. At a point on the Earth's surface, or also, it is the line along which an object will fall when dropped. Madulong man siya sa center of the gravity sa Earth. And we have also here another illustration. So, kung mag-meet si geoid, ellipsoid, ug ang terrain, so mao ni iyang mahimong illustration. So we have here normal to the geoid. Normal to the geoid is 90 degrees from the point with respect to the surface of the geoid. And we have also normal to the ellipsoid. So at that point, 90 degrees with respect to the surface ellipsoid. And that angle, kanang angle nga na-create between normal to the geoid and normal to the ellipsoid is what we call the deflection of the vertical. So let's define geoid again. Geoid is the equipotential surface of the Earth at mean sea level, or a level which oceans find a state of equilibrium. Diba? Ang pagkuha sa mean sea level is dili siya it's a long process, no? So in fact dapat 19 years, no? Continuous observation para lang makakuha ka og mean sea level. And from that mean sea level, i-extend na nimo padulong sa imuha sa landforms, then mo na siya ma-form nga geoid. So geoid is not perfectly regular due to the local anomalies in the gravitational field caused by non-homogeneous nature of the surface and substrata. So as you can see in the picture, no, dili gid siya regular, okay? Mura siya og kanang bato, no? Wala siya exact na shape. That's geoid. Another picture that shows the geoid. And ellipsoid, it is the simplest analytical figure to closely approximate the surface of the Earth, or the geoid. Since kinatay geoid, ang katong form, no, na nabuo sa geoid, i-approximate na siya para simpler ang ato ang formula, and of course simpler ang ato ang pag-derive of formula to get or to determine the different aspects. So analytical that approximates the surface of the Earth, or the geoid. An ellipsoid is simply the meridian ellipse that is rotated about its minor axis. So meridian ellipse, it's because in meridian, no, meridian nga meridian, in the meridian siya nga magtuyok, kay bali ang iyang axis is naa sa meridian, so mitawag siya og meridian ellipse. Minor axis, mubo man siya, mubo nga part, dilitong taas. So here is the illustration of the parameters of the meridian ellipse, starting with small letter A, which is denoted as semi-major axis, B as the semi-minor axis, F1 and F2 are the focal points, E as the linear eccentricity, and P is the point on the surface of the ellipsoid. And R1 and R2 are the radial distance from the focal points to P. So here are the important formulas showing the relationship of the parameters of the meridian ellipse, starting with the flattening. So it is denoted as small letter F. So flattening is equals to semi-major axis minus semi-minor axis all over semi-major axis, or F is equals to A minus B all over A. Next is we have first eccentricity. It is denoted as small letter E. That is equal to the square root of the semi-major axis squared minus semi-minor axis squared all over semi-major axis. So, or E is equals to square root of A squared minus B squared all over A. Next is the second eccentricity. So, same lang siya sa first eccentricity, but ang iyang all over is semi-minor axis na siya. And we have also linear eccentricity, so it is denoted as epsilon, that is equal to the square root of the semi-major axis squared minus semi-minor axis squared, or is equal to square root of A squared minus B squared. So we have also this important relationship, no? That is B over A is also equal to 1 minus flattening. That is also equal to the square root of 1 minus first eccentricity squared. And also, that is equal to 1 over square root of 1 minus second eccentricity squared. And also, again, equal to first eccentricity over the second eccentricity. And in this illustration, we can say that the radius 1 plus radius 2 is equal to 2 times the semi-major axis. So, at any point on that ellipse, the radius 1 plus radius 2 is all equal to the twice of the semi-major axis. So, let's go now to the geodetic Earth model. So, geodetic Earth model is used as the reference for the actual surface and external gravity field of the Earth. That is this provides a good fit to a geoid and to the gravity field. So, ako nang i-discuss kaganina nga si ellipsoid mao siya ang approximate, no, or mo fit in sa geoid. Siya ang mo fit sa geoid. And this model is simple and serve as a standard for application not only in geodesy and cartography but also in astronomy and geophysics. So we have the coordinate systems based on the ellipsoid. First is we have the x, y, and z Cartesian coordinate system. So ang origin ani niya nga system is ang center sa ellipsoid or katong tunga-tunga, no? Center sa ellipsoid. Ang z-axis mo coincide ni siya with the minor axis of the ellipsoid or katong b, no? Sa b siya dito siya mo coincide si z. So ang yan general formula is ang x squared plus y squared over semi-major axis squared plus z squared over semi-minor axis squared minus 1 is equal to 0. So mao na iya ang general formula. We have also ellipsoidal coordinate system, and in this coordinate system we have what we call geodetic latitude, that is denoted with that sign, no, Greek letter or that another Greek letter. And we have also second parameter, which is the geodetic longitude. So let us define the geodetic latitude. So geodetic latitude is the angle measured in the meridian plane between the equatorial plane of the ellipsoid and the surface normal to point P. So sa pasabotan niya, sir. No, so again, geodetic latitude daw is measured at meridian plane. So pag mo yung meridian from north padulong sa south, kana nga plane mo ni siya ang meridian plane at point P, no? So ang geodetic latitude daw is from equatorial plane. So pag mo yung equator is 0 latitude, no? From this equatorial plane padulong sa katong normal daw sa point P. Pag mo yung normal, that is 90 degrees. So from point P, diri sa point P natay tangent line diha, mag-imaginary tangent line ta, and from that tangent line makabuo ta og 90 degrees, and that line is the normal line of the point P. So from the equator daw, equatorial plane padulong sa normal line, no? Normal line sa kanang point P. So mao nang gitawag nga geodetic latitude. Next is si geodetic longitude. Geodetic longitude po is the angle measured at the equatorial plane. So ganina, geodetic latitude is sa meridian plane. So geodetic latitude po karon is ang in the equatorial plane na po siya. So between 0 meridian and the meridian plane of point P. So let's say that this is the 0 meridian or the Greenwich. Gikan daw diha padulong sa meridian plane sa point P. So ngayon sa pasabot sa meridian plane from north to south nung maigo siya sa katong point P. No, so mao ni karon ang iyahang meridian plane. So gikan sa 0 meridian padulong sa meridian sa point P. Dira padulong diri. So mao na siya si geodetic longitude. And the ellipsoidal meridian plane is formed by the surface normal at z-axis, and the 0 meridian plane is usually chosen as the meridian plane passing through Greenwich. So ang pabalo naman ta ng atong 0 meridian is naa sa Greenwich. And let's take note that si latitude is always from 0 to 90 lang gina siya. It's either north or south. 0 to 90 lang na siya. Walay latitude niya 110, no? 90 ra jud na siya. And for longitude, it's the angle is from 0 to 180. It's either east pud siya or west. So here are the relationship between the Cartesian and ellipsoidal coordinate systems, no, kaning mga formula. So pero ning i-recall kay naana pud ni sa inyong geometric geodesy. So let's take note nga si P is the radius of the circle of latitude. And we have also spatial geodetic coordinate system, or kanang gitawag na before nga space rectangular coordinate system. So mao na siya sa geodetic geometric geodesy. So the ellipsoidal surface or geodetic coordinate system can be extended to a spatial system by introducing the heights, no? So diri ang coordinate system di take account na niya ang heights, no? So from the ellipsoid plus h, no? Ellipsoid plus h, ang kana nga h is the height of the point P above the ellipsoid measured along the surface normal. So point Q, no? Kasi point Q is obtained by projecting the point P along the ellipsoidal normal, no? I-project siya, so pasaka, no? So mao man ni ang point Q, for example mao ni ang point Q, so naa siya height nga from P to Q, so naa siya h, no? So ang kaning h mao ni siya ang height. Okay, we all know nga it's not always nga ang terrain sa surface or earth surface is mo coincide siya always sa ellipsoid. So na mo siya musaka, mababa na pod. So at this point, so mas taas siya kaysa sa ellipsoid. So i-project siya padulong sa point P. So we have also a spatial coordinates, si latitude, longitude, and na po siya height. So it is designated as the geodetic coordinates. And in geodetic surveying, we are interested in determining the geodetic coordinates of points on or near the surface of the earth. So mao ni ato ang take into consideration. So here are the examples of the ellipsoid. Anong daghan mo klase ng ellipsoid? It's because mo depende siya kung kisay nag-model or kisay nagbuhat anang model sa ellipsoid. And in the different parts of the world is naa siya kasi klase ng ellipsoid yung ina-adapt. Magdepende siya kung asa siya best mo fit. Okay, we all know nga si geoid is dili siya irregular ang iyang shape. So magdepende pud siya sa giun sa pag-approximate ang ellipsoid based sa geoid, no? So sa atong makita diri na ay klase-klase no nga ellipsoid, si Clark 1866, si WGS 84, si GRS 80. So in every country ga-adapt sila og kung unsay best nga mo fit sa ilang nga ellipsoid. And of course naadjud na siya different na mga what they call this one, different deviations, no? For example kani from the center of the earth, si Clark Spheroid 1866 naa siya difference nga 236 meters sa center sa earth. And we have also si GRS, no? Nga naa siya 2 meters, no? From the center of the earth. So example is si Geodetic Reference System 1980 or kanang gitawag natong GRS 80 ellipsoid. And kani si World Geodetic System WGS 84 ellipsoid. So mo ni siya ang gina-adapt worldwide. Pero it doesn't mean na i-adapt pud siya sa tanan countries, no? So worldwide lang siya nga system para naibasihan. Pero in different countries naa po sila lahi-lahi nga ellipsoid. And lastly, we have Clark 1866 ellipsoid, which is mo ang ginagamit sa Philippines. So here are the ellipsoidal parameters. So the Clark 1866, we have the semi-major axis of 6378206.4. And iyahang inverse flattening or 1 over f is equals to 294.9786982. Si GRS na siya semi-major axis na 6378137. And naa siya inverse flattening at 298.257222101. Sa WGS 84, same lang sila ni GRS og semi-major axis, and nag-differ lang siya sa inverse flattening na 298.257223563. So the local relationship between the geoid and the ellipsoid. So mao ni siya ang formula nga i-introduce kaning si diba nato nang gi-define ganina nga kani si h is mao ni siya ang ellipsoidal height. So that's mean ellipsoidal height is the height of the earth's surface above or below the ellipsoid. So kung mao ni si ellipsoid from the earth's Earth's ellipsoidal height is the height from the Earth's surface above or below. So kung mo ni ang surface, Earth's surface, ay mo maning terrain. Mo ni ang ato ang usual nga terrain sa ato ang surface sa Earth. From that point, is for example, this one. So from this point, padulong daw sa ellipsoid, mo na siya si ellipsoidal height. So si H. And karon, si H na pod is si orthometric height. Orthometric height is the distance between the Earth's surface and the geoid. So from balik ta diri ang point kani. So from that padulong daw sa geoid kanang blue. Si geoid, which is normal daw ang point. So kung normal pasabot 90 degrees again, so magpapag tangent line diha 90 degrees. So kani nga line mo ni siya ang normal line sa kani nga point. So mo-coincide siya ana nga line. So from that point pagdulong sa geoid, so mo na siya si orthometric height. And si N is the geoidal undulation. It is the distance between the ellipsoid and the geoid. So ang kaning example, kaning gamay nga distance sa blue ug sa red, mao na siya ang geoidal undulation from geoid to ellipsoid. So from that relationship, makakam up ta ani nga formula na si HDI, which is ellipsoidal height, is equals to orthometric height plus geoidal undulation. And I guess and I hope na nasabtan ninyo ni before pa lang sa inyong geometric geodesy. So some notes for the review of geodesy. The physical shape of the Earth is closely approximated by mathematical surface of the ellipsoid. So, physical surface, from what akong i-discuss last time, na natay surface, tapos i-approximate din siya mathematically to the mathematical shape of the Earth, which is the geoid. And from the geoid, ana din siya ellipsoid para mo-fit in ana nga geoid. The ellipsoidal surface is smooth and convenient for mathematical operations. So let's agree with that. It's because geoid is irregular, diba? Ito ang i-discuss a while ago. And this is the reason why the ellipsoid is widely used as a reference surface for horizontal coordinates in geodetic networks. Okay, since smooth man siya and na siya geometric relationship, so gamiton lang na siya for horizontal coordinates in geodetic networks. Take note ha, horizontal coordinates. And the ellipsoid is not suitable as the reference surface for the vertical coordinates such as orthometric heights or elevation. As we all know nga si ellipsoid is ang smooth, no? Smooth siya nga surface. And dapat siya mga mathematical formulas and parameters to determine the coordinates, no? Coordinates of that the horizontal coordinates of that point, specific point. So dili siya pwede gamiton sa vertical coordinates or kanang height. And we all know nga ang surface sa Earth is irregular. Mubaba siya sa ellipsoid, pero sa musaka siya sa ellipsoid. So ang gamiton na niya nga surface is ang geoid. So a geoid is used instead in the vertical coordinates. And when using a geoid as a reference surface for orthometric heights, it is evident that the geoid undulation must be known. Geoid undulation kay nga naman, from this relationship kaning si H is equals to H plus N. H plus N. So from the surface of the Earth, okay, kuan man siya kanang irregular man siya. So makakuha ta og ellipsoidal height, no? Ellipsoidal height. And gusto na to kuhaon si orthometric height, no? Or ang kanang ginatawag na to og elevation. So makakuha ta ellipsoidal height, no? From the point of the surface of the Earth padulong sa ellipsoid. Ang ato lang karon is ang kaning N. Aha man ni pangitaon si N, si geoid undulation. Dapat mahibaw-an ni siya. Asa man ni siya pangitaon, sir? So, how do we determine N or the geoid undulation or geodesic separation is the use of the geopotential or gravitational models. So, for example, kani siya from the EGM 96 geoid models in meters, no? So makita ninyo na By the way, kani si N, no, mo ni siya ang separation or the distance between the geoid and the ellipsoid. So as you all know, kanang red na part, grabe ka red na part, 80 meters ang ilahang difference, no, between the ellipsoid and geoid. And kaning si blue, muna siya ang pinaka lowest pod na figure, which is negative 100. So from that, makuha na to dayon si orthometric heights. So example of this geopotential and or gravitational models is kaning gitawag na to si EGM 96, kani siya ang model. And napot na gitawag nga EGM 2008. So makuha ninyo na siya through their websites. So here is the Philippine Geoid model or PGN 2006. So mao pod ni ang geoid model sa Philippines, no? So this is from NAMRIA, by the way. So makakuha mo ani niya via this website. So values are the geoid heights or N reference with the WGS ellipsoid. So ellipsoid ni siya sa WGS kay since WGS is the worldwide man siya adapted na ellipsoid. So before we go further class, so let us differentiate what is geodetic and geographic coordinates. At wasang i-define kay basin na confuse mo unsay day kalainan ana nila sir or parehas na ba na sila sir, no? So let us differentiate them. In many mapping textbooks, you will often find that the latitude and longitude or kana nga denotation is referred as geographic coordinates of a point, di ba? Murag mao gid na implementin niyo makitaan sa mga textbooks. Pag kanigani nga Greek letter kay latitude dayon, pag kani is longitude, geographic siya. Geographic coordinates are the general position, no? General position of the points on the surface of the earth, used basically in mapping. So mo ni siya ang generic jud na term, no? Geographic coordinates. But in geodesy, geographic coordinates can be either geodetic or natural. So in many textbooks, kasagaran ang term jud sa coordinates is geographic. But in geodesy, it can either be geodetic or natural. So natural coordinates, also called as astronomic coordinates, that is strictly based on the physical properties and are unique at each point of P. Natural coordinates, astronomic, so sa astronomy ni siya nga aspect. And these curvilinear coordinates are directly determined from observations. Observations sa stars and quasars. Therefore, they refer to the instantaneous Earth's rotation axis and equator. The normal to the ellipsoid is replaced by the direction to the plumb line. So, natural coordinates is from the what they call this one? Astronomic observation, directly from astronomic observation. While si geodetic coordinates, so mo tong i-discuss sa ganina, no? Si latitude o si longitude. So let's go now to the reference system and reference frame. So again, recall na po din sa inyo ang geometric geodesy. Saan nila reference systems? So reference system is a complete conceptual definition on how the coordinate system is formed. So reference system is conceptual or the whole concept kung diyon sa pag-form ang isa ka coordinate system. It defines the origin and orientation of the fundamental planes of axis of the system, and also includes the underlying fundamental mathematical and physical models. So since kay conceptual man siya, so it's underlies with the fundamental mathematical and physical models. And sa reference system is the unattached to the real world, floating pa ni siya. Reference system kay concept pa man siya or conceptual framework pa man siya, wala pa man mo siya na georef kumbaga, no, or kung sa GIS pa is wala pa nimo siya na georef kay unattached pa man siya. And for reference frame, it is the practical realization of the reference system through observations. So mao ni siya ang application, no? Kay since na naman tay concept sa reference system, then we should be apply this as a reference frame. Again, it realizes the reference system by means of coordinates of definite points that are accessible directly by occupation or observation. So ang output aning output sa reference system is ang reference frame. Ang kanyang reference frame mo na nato makita karon nga mga geodetic control stations and networks. So by the way, simple analogy lang ani niya, no? Si reference system mura na siya og kanang resita, no? Resita sa doctor. Resita sa doctor, it's the whole concept. So you are floating pa siya or murag dili pa siya dayon ma-realize kung dili nimo na siya paliton. So kung naka-resita, ang katong resita mo to sa reference system, and kaning sa reference frame is ang katong tambal na nga imo nang gipalit, no? Kay concept pa man tong resita, dili pa man to nimo mainom dayon. So we need to buy those medicine for you to become healed, no? Or maayo ka. So pag inom nimo sa tambal or pag naa na ang tambal sa mo si reference frame. Another analogy of the reference system versus reference frame is a chess board and a chess pieces. So without a reference frame, the coordinates of control points are like chess pieces without a chess board. Ano man? So kung nalagi tuod kay reference frame na kay mga points, na kay networks, pero kung dili na siya naka-attach sa reference system, useless na siya. Mura kang nag-chess na walay chessboard, no? Sige ra ka og butang og kanang imo ra ni ibalhin-balhin ang kaning mga pieces, pero wala kay kaning chessboard. Unsa day ay mura kang naga-move lang ka ani nga mga pieces, pero wala ni siyang chessboard. They can be arranged again. They can be arranged daw, analyze and move, but they have no meaning. Wala siya meaning kaya nga naman wala man ning chessboard. Sige ra ka og abante sa kaning kuan ay imo ning iiswag, no? Pero unsay sukbanan nimo anong diya nimo gibutang, no? Ang kanang isa ka chess pieces kung wala ning chessboard. So useless siya, wala siya meaning. So same sa reference frame, no? Kung kani si reference frame kaning mga chess pieces, useless ni si chess pieces kung wala ni si chessboard, which is ang reference system, ang concept. So dili mabuo nga dula again kung dili ni kompleto ang duha. And let's go to the discussion of the geodetic datum. Geodetic datum is the set of parameters that describe the relationship between the particular local ellipsoid and the global reference system. So, again, it is a set of parameters, no? Siya ang mo describe between the particular local ellipsoid and a global reference system. Geodetic datum is defined by a set of at least 5 parameters, namely, say my major axis, at least 5. Pero pwede siya dugangan. Flattening and kaning coordinates of a point. Kaning si A ug si F sa imuha ning ellipsoid. And dapat na akay X, Y, and Z. Point of origin. Imo kay mao na po na imong gamiton para makakuha na po kag another nga coordinates. So that's for geodetic datum. At least na akaaning 5 parameters. Major, flattening, ug ang coordinate sa origin, point of origin. And geodetic datum is also a set of parameters and constant that defines the coordinate system, including its origin and its orientation and scale in such a way as to make this accessible for geodetic applications. Datum is ang katong sinugdanan, no? Mura ito na siya tulo ka coordinates, si X, Y, o si Z, kay na kay point of origin para maot na po gamiton nimo, and dapat accessible siya, accessible for geodetic applications. Kaya dito naman po mag-type type point. Type point siya na kung sa another na survey. So that's geodetic datum. Types of geodetic datums is we have horizontal geodetic datum. It's a geodetic datum for horizontal geodetic control, in which points are mapped into specified ellipsoid. So again, ellipsoid siya kay mao man siya basis for horizontal coordinates. So this datum is two-dimensional only. So horizontal is two-dimensional in the sense of two coordinates, C, latitude of C, longitude, are necessary and sufficient to identify a point. So X and Y lang siya, since horizontal man. And next type is the vertical geodetic datum. It's a geodetic datum for vertical geodetic control, in which points are mapped to a geopotential. Usually, this is for heights. That is one-dimensional na siya. See, H man, so Z lang siya. So one-dimensional that requires the value of a single parameter, which is the mean sea level. Example niya, mean sea level. So originate lang siya sa isa lang ka point. So examples of geodetic datum is the WGS 72 or the World Geodetic System 1972, WGS 84 o si PRS 92. May mga example sa horizontal datum. And in case of the Philippines, we have the PRS 92 datum or the Philippine Reference System of 1992. So formerly gitawag ni siya og Luzon datum of 1911. So it is the defined ani niya is ang geographic coordinates of the triangulation station of the Coast and Geodetic Surveys known as the Balanakan. So si or kaning si PRS na gito datum is also known as the Balanakan Station. So mao ni siya ang forma. Bato na siya nga dako na naka-usli na part, no, which is kani siya. Ilaha lang gidrill butangan og sign para sa mao ni siya ang origin, no? Origin sa geographic coordinates in the Philippines, si Balanakan. So makita na siya sa again sa Marinduque province, no? Marinduque province. So mao ni siya ang iyahang parameters. Si Balanakan Station or si PRS 92 datum, iyang spheroid or iyang ellipsoid is si Clark 1866, and nasa'y N or ang kanang geoid spheroid separation is 0.34, and mao ni iyang coordinates nga N north 13 degrees 33 minutes 41 seconds, and si longitude niya east 121 degrees 52 minutes of 003 seconds. So here are additional notes for PRS 92. So PRS 92 or the Philippine Reference System of 1992 is the homogeneous national network of geodetic control points or GCP marked by survey monuments or muhons that has been established using GPS technology. So ang pag-establish ani niya, so since same naman siya nga station sa katong Luzon datum 1911, but ang kaning si PRS 92 is occupied by siya or established na siya using GPS technology. This is by virtue of the EO 45 last January 5, 1992. PRS 92 became the standard reference system for all surveying and mapping activities in the Philippines. And the order also mandated that all new surveys and maps shall be referred to the new network of all old surveys shall be integrated, and all old surveys shall be integrated into it. So muna nang gi-adapt sa Philippines. Yung old, di-convert na siya into PRS 92. We are now down to the part 4, which is the last part of this lecture, which is the overview of control surveys and geodetic control network or GCN, establishment and densification. So let's recall what is a control survey. So ato naman nag-discuss ganina, so ato siyang balikan. Control surveys are surveys conducted to determine the horizontal and vertical positions of points which will form part of a geodetic network or a project control. over an area which will subsequently become the basis in determining the rectangular coordinates in the area. So control surveys are the surveys that will conducted to establish the control networks or control points. So there are two classes, which is the geodetic control surveys and the project control surveys. Project control surveys, again, it's a surveys conducted to establish the position of points of reference for projects with a limited geographic coverage. Limited, gagmay lang siya. Kasi project is under na siya pang geodetic control surveys. So, example sa geographic coverage na nga pwede siya sa project control surveys is ang municipality, a large isolated tract of land, a group settlement, a barangay, or a group of municipalities. And project control surveys covers the third order and fourth order level of accuracy. So, small siya of accuracy kay since si geodetic control surveys are the highest order of accuracy. And geodetic control surveys, speaking of, so this is the surveys conducted covering extensive area which will take into account the curvature. Curvature kay dagko naman siya areas, mo cover naman siya pila ka kilometers nga distance. So kinahanglan jud na siya i-take into account ang curvature and the geospheroidal shape of the earth. For the purpose of establishing basic network for control points covering the first and second order controls or first and second order of accuracy of controls. And geodetic control surveys is also known as geodetic surveys. So the general types of control surveys, we have horizontal control surveys and vertical control surveys. So when we say horizontal control surveys, it is conducted over a large areas, and these surveys is generally to establish the geodetic latitudes and longitudes of the station. Okay, horizontal, so two-dimensional lang gid siya. And when performed over small areas, plain rectangular coordinates is determined directly without obtaining geodetic latitudes and longitudes. Okay, ginagmay raman siya. So, pwede rin siya malabugan din ang coordinates directly. So, for the methods, here are the field procedures for horizontal control surveys. We have traversing, so kasayod naman tanong kung saan yung traversing, triangulation, and trilateration. And also we have this additional one is the global navigation satellite system based method. So kanina may mga GPS based or GNSS based na siya nga method. So traversing, so it is a series of horizontal distances and directions that is observed to connect points whose positions are to be determined. Series lang siya of horizontal distances. Horizontal lang, it's two-dimensional lang siya. And traverses of control surveys consist of closed polygon. Kinahanglan siya i-close para ma-check ang iyahang error. And kung namanggaling error, ma-distribute siya between stations. And traversing is less expensive, kay maaman jud ang traditional, and can be extended in any direction. So flexible ni si traversing. And traversing requires all station are intervisible. Kinahanglan makita gid nimo ang mga stations kay you cannot directly get the relationship between those points kung dili siya visible. Dapat visible siya. Balo naman taana. And the main disadvantage of traversing is there are fewer checks available when there is a need to locate surveying errors and mistakes. Wala ta kabalo asa nga corner ang pinaka-erroneous dito nga part. So ang ato nang ginabuhat is distribute lang nato siya. Di nato mahibaw-an kung ang hadatot ang pinaka-dakong naka-counterpart of error. So i-generalize na lang siya para i-distribute ang error sa tanang stations. Next method is the triangulation. So, triangulation employed over large areas where the methods of traversing would not be expected to maintain a uniform high accuracy over the entire area. So since kilagyo naman kaayo siya, so dito nato siya ma-sustain no ang traversing kay tungod lagyo na ang stations nya kinahanglan na gid siya og kanang mas kinahanglan na gid siya another method for establishing control. Di na jud pwede or dili na feasible si traversing. So kani sa triangulation ang gamitan. And of course, kuan po siya to maintain the high accuracy. Okay. Triangulation is kuan man siya using angles, no? Using angles kaya nagtawag siya triangulation kay angle ang basis. So triangulation is consists of networks of geometric figures with all the angles measured directly. Angles are measured directly in the field with relatively few of the sides are measured. So ang i-measured lang niya is ang baseline o ang check base, no? Sa distance. So angles ang gamiton tapos na lang siya few nga distances nga gamiton. And the length and direction of the lines joining these distance points are also determined after these surveys. So i-check siya, no? And advantage of triangulation is checks can be made in calculation while moving through the system by more than one possible route. So tungod kay flexible man si triangulation, so there are pwede ka maka-check sa imong error, no? While you are in the process of triangulation or bisan pag dili nimo kintahay wala pa ka-establish og next na point, pwede nimo ma-check kung unsa ang error or asa ang kung nanabay error. So these are the steps in triangulation, no? So baseline mo ni siyang motong pasabot na ganina nga si triangulation is na siya fewer distances lang o fewer sides are measured as a distances, no? So kani or baseline 1 i-measure ni siya ang kaning baseline 2 mo ni pang checking, so measure po ni siya. So steps are the baselines 1 and 2 are measured and all angles of triangles are measured. So i-measure ni siya, i-measure po ni tanan angles na nakasulod na nga triangulation network is i-measure siya. And the sides of the triangles are computed from the few given, no, na kaning baselines. So naman tay isa ka measured distance tapos napunta yung mga angles, so possible nga makuha nato ang uban nga distances or sides. So computed length of BL2 or baseline 2 is compared in the measured length of BL2. So naay measured tapos naapoy computed, so from that maka-determine ta kung unsa ang hadapit ang error ato siyang i-compare. Next is the trilateration. Si trilateration code is also employed, no, in large areas or methods of traversing. So save lang siya sa triangulation, no, para ma-maintain pod ang high level of accuracy. So again, it consists of networks of geometric figures pero sides na ang basihan. Sides are measured directly in the field. Triangulation, angles man to, no? Tapos from the angle, kung ano to ang all sides. So dili po sa trilateration, sides ang i-measure directly tapos ang angles are being computed. And considered to be the most accurate among three methods because distances are measured more accurately than angles. Mas ma-measure man nato o mas accurate ang distances compared sa angles. An advantage po sa trilateration is checks can be made in the calculation while moving through the system by more than one possible route. So save na ni siya sa triangulation na advantage. And we have here the GNSS based methods. So GNSS equipment and procedures are employed to determine the geodetic coordinates of the station. So naatay base point, naatay isa ka base na gitukuran, and we have rovers na moto siya ang mo occupy sa gusto na to kuhaan ng point, kuha na to coordinates na point, and requires a minimum of 2 stations to be occupied simultaneously. So mo akong itawag na naa siya duha ka known para makuha na to ang isa ka unknown. So since kay ang GNSS receiver is naman siya isa ka base o duha ka rover, pero ang kanang duha ka rover na GNSS receiver is pwede niya siya magamit as a base. So dapat na kay duha ka type point or duha ka known coordinates point, and ang isa dito nimo i-occupy sa katong gusto nimo kuhaan na station. So next general types of control surveys is the vertical control surveys. So natay horizontal, natay vertical. So the main objectives of the vertical control surveys is the establishment of the network of reference benchmarks, or kanang gitawag na to og BMs, no, or benchmarks. And the elevation of these benchmarks are determined usually with respect to the mean sea level or some other preferred datum. So sa Philippines, si mean sea level man atong basihan. So these are the methods in the vertical control survey. So we have barometric leveling, trigonometric leveling, differential leveling, which is the most precise one method of the vertical control survey. And for vertical geodetic, in the differential leveling, no, for vertical geodetic control establishment, a type of differential leveling called geodetic leveling is employed. So geodetic leveling, mura pun siya og normal na differential leveling, but taking into consideration the curvature of the earth sa elevation. And here are some remarks on geodetic control surveys in the Philippines. And all geodetic control surveys shall be conducted in the Philippine Reference System of 1992, or the PRS 92, using the survey grade GNSS receivers. Kinahanglan survey grade na siya, or ato nang employed niya GPS technology for the all geodetic control surveys in the Philippines. And here are the references and further readings. So if you want to explore more about this topic, so we have references from Anderson, Davis, Gilani, Kersley, and Torgate about geodesy and all about geodetic surveying. And I am going to require you to read the DENR 1998 Revised Manual of Land Surveying Regulation in the Philippines, or kanang gitawag na to DAO 1998-12 or DAO 98-12. So available at this website. And another one from DENR 2007, the Revised Regulation on Land Surveys, DENR Administrative Order number 2007-29. This is available online at this website also. And another further reading is the required reading is from DENR 2010, the adoption of the manual on the land survey procedures, or the tawag na to og DENR Memorandum Circular number 2010-13, available also on that website. So these three readings, no, is maghatag kog quiz ani siya, nilang tulo. So abang-abang lang sa ako ang instructions about this one, pero please read in advance about these three manuals, no, in geodetic surveying. Kay mao ni ato ang Biblia sa geodetic engineering. Biblia ni siya. And also required reading for control surveys. Please read in Laput, the Higher Surveying 2nd edition, chapters on control surveys, pages 155 to 260. So again, DENR manuals, DAO 1998-12, DAO 2007-29, and DMC 2010-13. I will be giving quizzes in this manual. So better to read in advance about this one, para pag magpa-quiz na ko, ready na mo. And for your questions regarding these lectures, you may message me through our FB page, and ask me if you have any clarifications and question about this topic. Again, thank you so much for watching this video. I hope it helped you and in studying geodetic surveying, especially in the new normal. Keep safe, everyone. and see you in our next video.